Hi Aaron, this is just a brief video about question number 96. Which of the following is not associated with rising air motions? And then we have our choices A, B, C, and D. But before we look at those particular ones, I'd like you to look over to the right side of this page. You'll notice here that I have drawn the ground, representation of the ground, and you can tell that because of the 45-degree angle line segments. That's how I delineate the ground or the surface. And you'll notice that I have pressures here, 1,000 millibars at the surface, and then I've drawn two lines which represent a column of air in the atmosphere. So you'll see I'm basically tracing out what I have already drawn on here. So in between these two line segments, I have these air molecules, such as nitrogen, oxygen. In fact, all these little dots represent gases in the atmosphere. And you'll notice that the concentration of nitrogen, oxygen, water vapor, CO2, is concentrated in the lower portion of this column of air that goes from the surface on up into the atmosphere. And you'll notice that I have represented here a decreasing density of gases such as nitrogen, oxygen, and so on as we go up to 250 millibars. So this is the halfway point of the atmosphere here, roughly, 500 millibars. And so what we can do, you'll notice here I have a little stick figure down here at the bottom representing a person. And you'll notice that above this person's head is a column of air represented by all of these gases that I'm showing here within this particular drawing. Now, if we want to get rising air in a column of the atmosphere, one way we could do this is to begin to move out of the column of air these air molecules. Because recall from chapter 2, Aaron, pressure is defined by a force per unit area, and each of these air molecules in this column of air, such as nitrogen, oxygen, water vapor, CO2, etc., is exerting a pressure. In other words, it's exerting a force per unit area on this stick person's head. And so the more molecules we have in this column of air, the higher the pressure. But if I start removing air molecules out, and you'll notice as I'm moving these out of the column, these air molecules are diverging. And so we begin to lower the surface pressure. So instead of 1,000, now it may be 992 millibars. It's just an arbitrary number I'm choosing here. But you'll notice the pressure that each of these air molecules are exerting on top of the stick person's head is beginning to decrease as we move these air molecules up and out of the column of air. So if I take what we call diverging air, which I'm representing by these arrows of molecules that I'm taking out, if I have divergence aloft, in other words at the top of this column at about 250 millibars, then I have to replace the air with converging air at the surface. So as pressures begin to lower at the surface, 990 millibars from 1,000, we begin to bring air in from the east and west, or north and south, or a combination of all, to replace the air molecules that I'm taking out. So converging air at the surface, once it meets, it has two choices. It can go into the ground, creating these huge craters or potholes. We don't see that. So the only other option is that the air begins to rise. So air begins to rise as we pull molecules out of the top or out of the column of air, which reduces the pressure at the surface. With a reduced pressure, we begin to get converging air into the column near the surface. It converges. When I say converges, it meets and begins to rise upward. So, convergence of air at the surface, yes, that will lead to upward motion. Divergence of air aloft, yes, that will lead to upward motion. Because recall, we have diverging air as you see the arrows moving away from each other. So divergence here at the top. Let's see if I can change this a little bit. And then convergence of air at the surface. So those two areas will help lead to upward motion in a column of air. Now, what happens if we have... Well, before we do that, let me explain to you what overrunning is. And overrunning occurs, let's see if I can draw, I'm going to draw right here on the left side, the ground again. Again, these line segments, 45-degree angle line segments represent the ground. So this is the surface. And let's say that we have, let's see, a warm front. Now what you're looking at here, Aaron, is kind of like a side view in the atmosphere. So we have cool air here in this region and warmer air over here. Now, if we have warm air hitting a pool of cooler air, recall that warm air is less dense, it's lighter than cool air, so it will begin to run up and over the cool air. So you got the cool air here at the surface. You've got the actual warm front. I'll draw that. I'll draw a red here to indicate the warm front. This front is just a division between the cool air here at the surface and warm air also on the other side of it. And as this warm air hits the more dense cool air or cold air, it will begin to rise, creating precipitation where you have the air beginning to rise up. So this, and we call this overrunning, because the warm air is literally overrunning the cooler, more dense air, which leads to vertical motions or rising motions. So now you can see overrunning also produces rising air. So the only choice we have left, because the question asks, which of the following is not associated with rising air? By process of elimination, we've got convergence of air aloft. Now, I just don't want you to do this by process of elimination. I want you to understand what is going on. So give me just a moment here. I'm going to see if I can erase all of this. Okay, so let me again draw a column of air, just like I did earlier. It's supposed to be straight, but it's not. And again, the ground is represented here by these 45-degree line segments. And we've got a stick person here also. So when we talk about convergence of air aloft, we're talking about at the top of this column of air. If I have air converging like this and like this, when these two what represents air coming in from the left and right, when they collide at the top of this column, they will begin to move downward. And so air in this column of the atmosphere is moving downward. So if you have air converging at the top of this column, which is about 250 millibars, they will collide and begin to move downward. So now you get downward moving air to the surface. So it's like we're bringing these other molecules like nitrogen, oxygen, water vapor, CO2, and we're bringing them into the column of air and moving them down. So convergence of air aloft will lead to downward motions. I hope this is helpful, Aaron. Let me know, and have a good day.